Hello, future gazers and tech enthusiasts. Look around you. Whether you're in a sprawling metropolis or a quaint town, there's one ubiquitous piece of engineering, an unsung hero of urban development, that we often take for granted: the elevator. These vertical vehicles are far more than mere people movers. They are the literal backbone of our modern skylines, enabling us to build taller, denser, and more efficiently. Without them, skyscrapers would be impractical monuments, inaccessible beyond a few flights of stairs. But what happens when something so fundamental, so integrated into our daily lives, becomes a hot topic on a platform like Hacker News? When an article about the future of vertical transport rockets to the top of the most discussed list, it signals something significant. It means the tech community, a group notorious for dissecting everything from kernel updates to quantum computing, sees a revolutionary shift on the horizon. And that's exactly what happened when a deep dive into next-generation elevator technology captured the attention of thousands of developers, engineers, and futurists. Today, we're unpacking that Hacker News phenomenon, exploring why elevators are anything but boring, and how they're poised for a mind-bending transformation. For centuries, vertical transport was rudimentary at best. Think simple pulley systems, ropes, and manual labor hoisting goods and people. It wasn't until the mid-19th century that a pivotal innovation changed everything. In 1853, Elisha Otis introduced his groundbreaking safety brake mechanism at the Crystal Palace Exposition in New York. Picture this: a wooden platform laden with barrels, hoisted high above a crowd. Otis himself stood on it, a man with incredible faith in his invention. He then famously commanded the rope to be cut. Instead of a catastrophic crash, the platform jolted to a safe, albeit sudden, stop, held firm by his ingenious spring-loaded safety brake. That moment of dramatic demonstration wasn't just a spectacle. It was the birth of the safe passenger elevator. And with it, the dawn of the skyscraper era. Buildings could finally reach for the clouds, confident that their occupants could ascend and descend safely. Otis's invention, powered first by steam engines and later by electric motors and robust steel cables, became the gold standard, a testament to mechanical brilliance that has largely remained unchanged for over a century. So, why did Hacker News suddenly care about a piece of technology that, for most, has been a solved problem for decades? The discussion wasn't about the current state of affairs, but rather the asterisk limitations of the traditional rope-based system and the radical solutions emerging. The core of the debate revolved around efficiency, speed, capacity, and architectural freedom in increasingly dense urban landscapes. Traditional elevators, with their counterweights, heavy steel ropes, and singular vertical shafts, face inherent physical constraints. The taller the building, the heavier and longer the ropes, and the more shafts are needed to serve the building adequately, eating up valuable floor space. The Hacker News thread was abuzz with comments about optimizing traffic flow, reducing wait times, and pushing the boundaries of what vertical movement could achieve. This brings us to the future. A future that is, quite literally, ropeless and multi-directional. Imagine an elevator system that doesn't rely on steel cables at all. Instead, individual cabins glide silently on a network of tracks, propelled by linear motors, the same magnetic levitation technology found in high-speed trains. This isn't science fiction. It's here. Companies like ThyssenKrupp have pioneered systems like multi, which eliminate ropes entirely. Each cabin becomes an independent, self-propelled unit capable of moving not just vertically, but horizontally as well. Envision an entire building's circulatory system, much like a metro network, where cabins can transfer between shafts, move around corners, and serve multiple destinations simultaneously. This magnetic levitation drive system drastically increases transport capacity, potentially by up to 50%, while reducing the elevator footprint in a building. Architects are no longer constrained by the rigid verticality of traditional shafts, opening up unprecedented design possibilities for building shapes and internal layouts. The visual spectacle of multiple cabins moving independently within a single shaft, or even across different faces of a building, is truly something to behold. It's a fundamental reimagining, moving from a single point-to-point shuttle to a complex, intelligent vertical transit grid. But the innovation doesn't stop at ropeless movement. The next generation of elevators is also incredibly smart. We're talking about systems integrated with the Internet of Things, IoT, and artificial intelligence, AI. Smart elevators can anticipate demand based on real-time traffic patterns, weather conditions, or even scheduled events within a building. Using machine learning algorithms, they can optimize dispatching, group passengers intelligently, and even predict maintenance needs before a breakdown occurs. Picture this. You tap your smartphone or use a biometric scanner at the lobby entrance, and the system already knows your destination floor, dispatching the most efficient elevator for you, minimizing stops. These systems are equipped with sensor arrays, constantly monitoring everything from vibration and temperature to door operations and motor performance. This data is fed into predictive analytics models, ensuring maximum uptime and significantly extending the lifespan of components. They can even integrate with building management systems, adjusting lighting, HVAC, and security based on passenger flow. Energy efficiency is another huge win. Smart elevators can regenerate power as they descend, feeding electricity back into the building's grid, contributing to greener, more sustainable infrastructure. The conversation on Hacker News highlighted the software layer, the APIs, and the data analytics as crucial components.